Alright, so welcome to the last lab sheet. Okay, so this lab sheet is titled Populating the Cloud, and the purpose of this is to pretty much give you the tasks that you need to do for the remaining weeks in the module. Okay, now the tasks remaining are basically to build your own cloud. Alright, so far we've installed OpenNebula. We've built an example virtual machine so that we see how they're built, and we've set up some networking infrastructure in our cloud so that we can have lots of network cards to play around with. And now essentially is the time for us to give this cloud a purpose in life. Okay, so what we will be doing is we will be building a few virtual machines. I will give you the specifications for those virtual machines, and I will tell you roughly what I want them to do. However, from that point on, after the minimum requirement is met, you can do whatever you like. Okay, it's your cloud. The more you customize it and the more you build things on it and you introduce features and services onto it, the better it will be for, I'm going to say, your grade, but really I mean for you to learn how to do stuff in a cloud. Okay, so what are we doing? The scenario that we have is that essentially we're building a small cloud for the university. Okay, so we need to have different types of virtual machines in our cloud so that we can service our customers. Our customers are lecturers and students. Okay, so you're the administrator of the cloud itself, and your end users will be students and lecturers. Now they will have different requirements, and this means that the virtual machines that will serve each group of users will need to be different. Okay, so the easiest way to interpret this requirement is that you need to build at least 2 different templates for the virtual machines that you will have. So you should have one template for your lecturers, and you should have one template for your students as well. Okay. What this also means is that you will also need to be able to provide some services to all those people, to all those users. Okay, so you will need to have a server in place that is able to do, let's say, for example, user authentication and anything else you want from there on. The easiest service that you can offer is file sharing. All right, so you can install and configure NFS, Network File Service, onto your server, and you can share folders and files with your users. One of the things that you can do here, for example, is you can make sure that not everybody has access to the same files. Okay, so perhaps there should be a space, a folder that's shared in your server that is accessible only to lecturers, because, for example, that's where they put their assessments so that they can all see it and moderate the artifacts and so on. And the students should not really have access to this. Okay. You can also have another shared space that is available for everybody, both lecturers and students, and that would be a place where people can include software, materials, and so on, so that the students can actually access them and so on. Okay, so from that point on, I love it when they tap the card and they just walk away and I can hear the beeps. It's brilliant. Yes, I'm talking to you. Anyway, so virtual machine 1. Server, yeah? So we at the moment have different network cards in our system. Okay, so we have net 28, net 30, 31 and 32. The easiest way that you can split those virtual machines is to basically put them on a different subnet, on a different network. Okay, so there is an example in the lab sheet. So for example, you can use VMnet 30, so network 30, for your server. You don't have to strictly adhere to this. Okay, I'm not too fast about the networking aspect of it. I'm mostly interested in you keeping the networks separate. I don't care which ones you use. It would probably make sense, because your server is the machine that will require the most configuration on its software, that you actually keep your server on net 28, so it has direct internet access straight away, and you can install all the packages you like without having to depend on routing, so it will be one less thing to worry about. However, if you are confident in your networking and everything works and you're happy with it, then fine by me. You can put your server on VMnet 30. I don't really mind. I don't care. Okay. So your server should be installed and it should be named VFS. All right. And at the bare minimum, this should be a file server for the cloud. As we said, install NFS onto it. From there on, you can install whatever other services you like, and it's fine by me. The only thing that I have to recommend here is make sure that you make backups. So if you are going to configure a service and the service works and it's finished and you are thinking of configuring another service, take a backup before you do that. So for example, something that lots of students have done in the past is they've configured NFS and then they've added LDAP authentication on top of that. Okay, so that will help you if you turn your server into an LDAP server. That will help you authenticate all of your users centrally with an LDAP server, so you will have file sharing and authentication on that one server that can do everything. Okay, so once you do this, you have your server in place and it's configured. You should have a VM2 and a VM3, brilliant. So you should have a VM2, which should be your lecturer client. Now you need to think of how the lecturers will use the computers. Okay, they will need to be computers that they can use. They are theirs, they have their own hard drive, and all of the data that they store on them stays there forever. Okay, so you should be able to have a lecturer being in any of the lecture theaters or labs in the university. They should be able to just go into that local computer there, and they should be able to start up their virtual machine in the cloud, log in, and all of their personal information should be there. So all of their files, all of their settings, their wallpaper and everything else should come up straight away. Okay. This pretty much translates to the fact that each lecturer should have their own VM, perhaps even their own template as well. Okay. And mostly it means that their hard drive should be persistent. Okay. So it means that all of the data should stay there. You should then have another VM2, and this is a typo, I'm going to fix it. Yeah? So VM3, for example, that should be your student client. So this should be a virtual machine that should be available for the students to use. Okay, and the requirement for this is that they can come in, they can sit on a computer, log into any of the virtual machines in the cloud, use them, and then log out, and then the next user, the next student can come in and use those machines, and they should reset back to what they were before. So they should have an initial state of this is a brand new virtual machine that you're using, and when you log out, it reverts back into that. This basically translates to making the hard drive non-persistent for this. The other benefit to this is that if the hard drive is non-persistent, you can have multiple simultaneous instances of this virtual machine running. Okay, which is fine as far as the hard drives are concerned, but then that will pose a problem with the networking. Why? Because your networks, you have net 30, 31, 32. You have 2 IP addresses for each of them. So this means that when a virtual machine instance starts up, it gets the second usable IP address from whatever subnet it's on. This means that if you try to start another instance of the same template, let's say it's a student computer, then that will not have an available IP address to get because you've run out of IP addresses. Okay, very easy solution to this, bridge it. Use network 28. Okay, in fact, some students in the past have also created another network connection and they've called it net 29, because don't forget that our network 28 has a /23 subnet mask. So it means that any computer that is on subnets 28 and 29 are essentially on the same thing, on the same network segment. So they will have internet access. So if you start bridging addresses across 28 and 29, then you will figure out that for your students, for example, you can have multiple IP addresses. Essentially, you can have 4 bridged addresses on subnet 29 to use. Okay, so you could have your server on 28 or 30, it doesn't matter. You could have your lecturer computers on 31 and just start up one of it and do it as a proof of concept and show that it works. And you can have your students on subnet 29, for example, and you can have 3 or 4 instances of this running at the same time, and everything works. Whatever you decide to do, the first thing that you will need to do is create a network diagram. Okay, so you need to create a network diagram, and I definitely need to see this in your logbooks. Okay, in which you explain to me which virtual machines you're going to build, how many, how they will be connected, and how they will communicate with each other and with the host. Okay, so there should be a VFS, there should be a VM1 for lecturers, a VM2 for students, VM3 for students, VM4 for students, and so on. Okay, this will help primarily you guys so that you know exactly what you need to be building. Okay, it will be like a roadmap for you to know exactly what IP addresses, what network cards to allocate to which template, and how to start them up and how to configure them. Okay, now this is the bare minimum requirement. All right, you can really do anything you like from this on. And when I say anything, I mean anything. You can build virtual machines with Windows if you like. You can build Ubuntu virtual machines. You can really, I don't care. Yes, I've had students in the past. I've had a student that decided he didn't like Linux, so he just built all of his VMs in the cloud in Windows. But he had a Windows server that had everything: Active Directory, Hyper-V, absolutely everything inside it. Okay, so if you do want to go down that road, it's fine by me, as long as you explain what you're doing in the logbook and you meet the bare minimum requirement, which is one server, one lecturer, one student, and they should be segregated between them. Okay, you can add other services if you like. You can add automation. One of the things that you will soon find out is when you start up your virtual machines, you might have given them a network card, but when the virtual machines start, they don't actually have any network configuration inside of them. Okay, this is because you need to enable something that's called the contextualization on the networking for the virtual machine in the cloud, and then that should pass on the information from the network card that you've allocated to the virtual machine to the virtual machine's operating system itself. Okay, so there is really no limit to what you can do. You can automate as much as you like, as long as you make sure that you document everything in the logbook, and that's it. And I can give you some marks for it. Okay, this last lab sheet is worth significantly more marks than any other lab sheet in the series, in the module. Okay, so keep that in mind. So I can tell you, for example, the installation of OVS is the installation of Linux is 10 marks. The installation of OVS is another 10 marks. So we're at 20. Yes, the building the first virtual machine is another 10 marks. So that's 30. The familiarization with Sandstone is another 10 marks, and you've passed the module. That's 40%. Okay. Then there's another 20 marks for OVS because it's a bigger lab sheet. So if you complete that correctly, you can get up to 60%, which is a B. But to get an A, which is over 70%, so the remaining 40 marks of it are on this last lab sheet. Okay. The milestone for you to get an A is to have 3 virtual machines that are working and they can ping the internet. Alright, so this means that routing from OVS must have been working, obviously, but your 3 virtual machines must be built. They must be different templates, so you must explain how you built them, and they should be able to ping out the outside world. Okay, so it means that their networking must also be correct. If you have this, you're sitting at 70%, and you get an A essentially. From there on, if you meet the minimum requirements of building NFS, so file sharing and everything, and that works, and there is segregation between the students and the lecturers, you can go up to 80%. If you configure LDAP, you can go up to 90%. And then if you can do anything else, which is your idea on top of that, you can go up to 100%. This is, of course, assuming that you have the perfect documentation in your logbook up to the completion of those tasks, which means two things. You have all the screenshots, one. You explain all the screenshots, what you've done and why you've done it. Okay, a couple of you have given me drafts already to have a look at. Yes, they were mostly okay with the documentation and everything. You're good at taking screenshots. You need to explain. You need to explain what's happening and why. All right. So yes, you are organized, methodical. That's fine. You need to explain exactly what's happening in that screenshot and why. All right. And don't forget, during the Easter break or whenever you like, really, you can send me your logbook, and I can have a look at it, and I can tell you if you're doing it right or if you need to improve something, because I do want you to get an A, all of you. All right. So, it is a very flexible lab sheet as such. All right. There are lots of things to do. There is lots of work on it. However, you have next week and then 2 more weeks after that. So you have 3 weeks available to do this. And of course, don't forget all of Easter break as well, which is another entire 3 weeks. The lab will be open for open access during Easter. I had an awesome question this morning. Yes, the door opens if you scan your card on the thing. Yes? So there's your card reader, which is on the outside. And then right next to the door, there is another black oval shaped scanner. If you scan your card there, the door unlocks. Okay, so if you come and the door is locked, just make sure you have your student ID with you, scan it, because we need to know who's in there when we are outside of term times, essentially, so that we know who stole all the monitors. Now we're done, we have cameras as well, it's fine. Okay, so yes, any questions about this? Yeah, I will be here next week as well, so we'll have a lecture here next week as well, which will be the last lecture before the Easter break. Hopefully, most of you will have gotten into that part, will have begun with the lab sheet then, and then I will mostly use that session as a tutorial, so I won't record it and everything, to ask questions that you might have, help you out to draw your network diagram or whatever else you would like to do. Okay, so if you have no questions from me next week, don't come. But if you think that I can help you with something, then by all means, please come. Okay, all right, thank you very much.